Hello and welcome to another session of Fischer Firestop webinar. And this is a tri-series and you are all gathered here for the second series of this webinar. And I'm Naveen, today's host for the session. So there are some few do's and don'ts about this particular webinar. For better experience, please use only Google Chrome or Firefox, just because that we have experienced similar kind of or bad situations in terms of network and things like stuff with Internet Explorer. Please do not parallel downloads, just because that it could hamper your relay in terms of either in terms of video or in terms of audio. All the questions will be answered at the end. Please be patient and please use the question tab to answer or put your questions together. So this will be the interface that you will be looking in for, or you'll be familiar at this point of time. Use this double arrow mark to have a full view mode, and use the chat box to say hi, hello. Questions tab, especially, please use it for questions alone. And polls, finally, please use this poll. We value your feedback, and for our betterment it will be great helpful. So as we told, today we are part of the tri-series webinar, Firestop webinar. The first series already people have attended, many people have attended for this. Thanks for that. And that was basically in terms of basic Firestop solutions. And this one will be in terms of performance and setting up the defense. To explain this, we have two key people from the industry, and one is Mr. Muzaffar Ahmad Syed. He is the regional Firestop manager for Fischer, and here he has overall 10 plus years of experience in this construction industry, and especially 5 plus years of experience in with Fischer. And he has actually traveled across GCC and worked with major projects across GCC. His specialization goes in terms of Firestop systems, post-installed anchors, and installation systems. He has a very good certification from international accredited organizations like Institute of Firestop Fire Engineers from UK. This is one of the renowned institutions which actually certifies the key people, and if in case someone wants to register themselves or enhance their knowledge, this is one of the key institutions then one can go. And Mr. Muzaffar has been certified as one of the key person from them. He has more number of awards to his collection, and we welcome him onto the stage. And we have a other presenter from our end from Germany. His name is Konstantin Wiegert. He's the head of Firestop and facade systems. He constantly travels across the globe, so he brings whole lot of experience across from the globe. Most of the time he actually is in travel, and this is the first of the instance where he actually comes to the picture and helps us to get more insight about Firestop solutions. His experience is almost somewhere around 8 plus years of experience in Fischer and with facade and Firestop engineering. That's in a nutshell. Over to Mr. Syed Musaffar.
First of all, I would like to welcome all of you again, and it's a pleasure having you all here. Thank you very much for taking out the time and trying to learn about Firestop, especially Fischer Firestop. As Naveen said, this is the second part, and the first part could be viewed. I have just posted the link in the chat box. Now, there would be several questions that you might come up with that might be there in your mind. We request you to use the questions pane instead of the chat pane. So if you type inside the chat pane any questions, we might miss them. So try using the questions pane, and you can post any of your questions there. And without further ado, let me go into the details. So just to recap, sorry, give me a moment. Yeah, so I hope my screen is visible. So just to recap, in the first installment of these Firestop series, we had discussed some case studies concluding the importance of taking a balanced approach to fire protection, which should include active as well as passive systems. To understand better, we saw how fire behaves and understood the different stages of fire. When we saw the fire stop as part of the requirement of pacifier protection and different codes requiring the same. So let us continue our series and learn some important aspects of FIRESTOP technologies and system testing. Again, just to remind you, please post your questions in the question answer pane during the presentation anytime you get a doubt. We will collect all the questions at the end. We have a time about 15 minutes where we will try to answer as many questions as possible, and any missed out will be replied through email. So in this episode, we will discuss the FIRESTOP as a concept and delve into the technology behind the FIRESTOP products, function under fire conditions. Then my colleague Konstantin from our head office will discuss in detail about how the FIRESTOP systems are tested and certified. Finally, we go into the question answer session. Now, this series will not be talking about applications and the requirements of FIRESTOP itself. We'll be talking about only the specific topics related to FIRESTOP as a concept, as well as the testing and certification. So this would be wrapping up our second series, and then in the third series, we'll be looking at all the applications related to this FIRESTOP. So just as a concept, FIRESTOP systems are tested systems designed to reinstate the fire resistance of a given assembly after the fire barrier has been compromised by a breach. The breach or opening in the wall or floor would be required to make the building functional and cannot be avoided. For example, a wall that was constructed with a rating of 2 hours would be breached by an MEP contractor who comes and drills a hole to pass his service, thereby reducing the rating of this wall to 0 hours. He installs his service, but the rating still remains 0. The rating is only reinstated after an appropriate Fischer FIRESTOP system is applied, thereby ensuring the compartmentation that was intended. Now we should remember FIRESTOP is always a system, and rating is given to an overall system which includes the substrate, the penetrant, the backing material, and the Fischer FIRESTOP sealant. The sealant on its own does not have a resistance rating. So we will look a little bit more about resistance as well as reaction in the upcoming slides. Similarly, the civil joint between a fire-rated wall and the floor is inherently constructed with a breach. The Fischer FIRESTOP system is applied to get the rating that was required and close the breach. Again, the civil joints are also a system consisting of the substrate, backing material, and the Fischer FIRESTOP sealant. Examples of these breaches can be seen in building projects quite frequently. Flames, smoke, toxic gases escape from the compartment via these breaches as small as pencil hole. Now, oftenly the breaches are much bigger than the pencil hole that we encounter. Now, this completely compromises the fire life safety strategy of the building, thereby putting all the occupants at risk. Since there, in this image itself, you could see several types of penetrants that have breached the fire resisting assemblies. Since there are several types of breaches, we have a range of products that would be required to treat these breaches as well. Fischer, as a manufacturer, has FIRESTOP products to attend to all usual as well as hidden surprises that could occur on a project site. in terms of fire stopping. Now, these products are either sealants, sprays and coatings, wraps and collars, or some special products. We will see the use of individual products based on actual site applications in our final episode of these series. Now, many a times we get questioned on how these products generally work when exposed to fire. We would see what is the technology behind these FIRESTOP products and their behavior when they are exposed to fire. So our FIRESTOP products function predominantly and in four main types of ways when they are exposed to fire. So number one is called as intumescent. Now what you can see here on your screen is a small strip of wrap, which when exposed to fire expands. Now you can imagine that there is a big gap in the wall and you have a small strip that would have been closed that gap, but when there is a fire, it would expand and close that opening. Now intumescent could be of two main types. Either an intumescent without any pressure, thereby it wouldn't exert any pressure on the surface. So you could imagine a metallic pipe which would not require any pressure to close, or a plastic pipe which would require huge pressure to actually crush that surface itself, like wraps and collars. Similarly, the second type would be endothermic. So we have a product called FCPS, which is coated with an endothermic coating. Now, what this coating does is when it is exposed to flames, it releases water, thereby cooling down the environment at that particular location and preventing passage of flame and gases and heat through itself, thereby resisting again and ensuring the compartmentation is met. The third type is called as ablative or carbonization. So what you see in this image is a product called FIAM. After curing, when exposed to fire, it forms a charred coating on top of itself. This char is insulative in nature and prevents heat transfer from this particular location. Also, the sealant would prevent smoke and gases to pass through. So the product name is FIAM. Lastly, we have products which work on the principle of being just insulative. So what you see here in this image is a Fischer intumescent putty pad. All that the putty pad does is prevents flame and smoke to pass through it because it does not disintegrate when exposed to extreme heat. Similarly, we have a product called mortar, which would prevent passage of smoke, flame, gases through it just by being present and not disintegrating when exposed to flames. There are two aspects that are generally related to fire, which many people get confused with, namely reaction to fire and resistance to fire. When we talk about products or material, we are talking about reaction to fire. The reaction to fire is the measurement of how a material or a system will contribute to fire development and spread, particularly in the very early stages of fire where evacuation is crucial. The reaction to fire has several parameters that are being tested. For example, the ignitability, surface spread of flame, smoke develop, etc. of the product or the material under question. For example, under the EN code, the combustibility of a material is classified under several letters, specifically B class material, which is a combustible material. A simple exposure to flame of a commonly available PU-based foam can show the difference. For example, the B1 foam does not readily ignite. However, remember, it is still combustible. B2 category of foam is generally ignitable. Finally, the B3 foam, which just is used as a filler in openings, is highly combustible material or readily ignitable material. We should not confuse the reaction to fire with resistance to fire. Also, we should remember that the reaction to fire is not given in terms of time. So you cannot say that this product is having a reaction to fire for 4 hours, or it is not combustible to fire for 4 hours, right? So sometimes a product or a material which is not really good under the reaction to fire might be a very good in resistance to fire. So what we see here is a dry wood piece, which everybody knows that when it is exposed to fire will burn. However, if you go to any project site, you would see several of fire-rated doors which are constructed from plain wood. When we are talking about that rating, we are always talking about the resistance to fire. Now, resistance to fire is the measurement of the ability of a material or a system to resist and ideally prevent the passage of fire from one distinct area to another area. Let's go back to the wall that was constructed and reinstated. Now, if there is a fire in one area behind the wall, the resistance of fire dictates that this flame, heat, smoke, toxic gases are prevented from passing by through this fire-rated barrier to the other non-affected sites. Especially when you're measuring the integrity of the wall itself, as well as the insulation of this system as a whole that is in question. So generally, the resistance to fire is given as a time frame, a length of time that would be required for this assembly to disintegrate and allow passage of fire and flame and smoke and all of those gases. Right. These things are generally tested according to certain standards. Now, I would like to invite my colleague, Konstantin, to describe these test standards.
So hello also from my side, warm welcome from Germany and thanks for having me today. So Muzaffar explained to you the functioning principles of our products, and it's great to know that our products work well, but the valid question is, how are they tested and certified? And that's a valid question because in fire stopping, it is not possible to assess performances upon calculations. This is why testing and certification is really important to make sure the FIRESTOP applications are safe. Sometimes testing and certification is mixed up and the concept is subjected to common misconceptions. We will clarify this today. But first, Muzaffar, what are the relevant testing standards for the Middle East region?
Yes, Konstantin, that's a really good question. Now, in the Middle East, FIRESTOP systems again are accepted as tested systems, and there are several testing codes which give the parameters and procedures for testing. The Fire Life Safety Code specify the testing codes acceptable within their jurisdiction. For example, in UAE, the code that is in question is issued by the General Command of Civil Defense centrally, and it calls for ASTM E814, UL1479, EN1366 as the acceptable test standards, among others, for penetration fire stopping. Similarly, for the fire resistive joint system, ASTM 1966, UL2079, BSEN 1366, Part 4 are the acceptable codes, among others. Finally, for perimeter fire barrier system, the codes that are acceptable are ASTM E2307, BSEN 1364 Part 3, and Part 4 for perimeter fire barriers. Similarly, for other regions, including Saudi Arabia or be it Oman, all of these have similar test standard requirements. Right, Konstantin, I'm back to you on description of what these test standards call for.
Very good. So these are a lot of numbers and digits, and we start with explaining what is most important to judge these testing standards, and that's the resistance to fire. This is what it is all about. And the resistance to fire is the ability not only of a material, but of a system to resist fire over a certain duration. It is expressed in units of time, minutes or hours, and two main characteristics are usually measured. That's the integrity and the insulation. Now, let me explain how integrity and insulation is measured during a fire test. This explanation is very simplified, but it does explain the essentials. First, we use the example of a European fire test. Under European testing, the integrity E measures the time a system resists before allowing the passage of flames. Generally, the integrity is measured with a so-called cotton pad test. A cotton pad is placed upon suspicious spots that may occur during the fire testing, and then if the cotton pad ignites, then the test specimen is failed, and at this time, the time is recorded. The insulation or temperature rating measures when a test specimen conducts heat on certain areas as defined in the relevant testing standards. And this is usually done with a thermocouple that is measured when the time exceeds 180 degrees Celsius over the ambient temperature. This temperature is really important because 180 degrees usually is the self-ignition temperature of a lot of materials. Now, under American fire testing, then we call it F&T rating, and this is expressed in hours. And the rules are similar in their fundamentals. However, we have some differences that exist. Probably the biggest difference is explained on the next slide. This is the so-called host stream test. Under UL and ASTM testing, verticals are subjected to the host stream test. This means that a duplicate test specimen at half the duration of the original test assembly is impacted by a 30 psi water stream as specified in the standard from 20 feet distance. The objective is to prove the specimen stability. Under European testing, however, there is no requirement for a host stream test. However, the pressure of the furnace is different and the pressure gradient ensures the stability of the actual test specimen. We also have testing for secondary attributes, such as air leakage before or during the test and water tightness testing. These may also be important for certain products. These testing data can be included into the relevant approvals, or they can also be stated in separate performance documents. You can just speak to your Fischer technical engineers on the project to make sure to get the relevant information. But on the next slide, just let us take a look on the primary performance criteria for fire stopping. Here in this table, you can see an overview of different testing standards relevant to fire stopping. Despite some technical differences in testing, for example, the host stream test, as explained previously, all test standards serve the same purpose by providing a route for demonstrating the ability of fire-stopping products to maintain compartmentation. For penetration seals, as you can see on the left side, UL 1479 and ASTM E814, which are equivalent tests to achieve the F&T rating, which is expressed in hours. The European EN 1366-3 incorporates the testing of standardized system, and the results are then classified as per another standard. It's called EN 13512 as integrity E. That would be equivalent to the F rating, and the insulation EI, which would be equivalent to the T rating. The same principle really applies for the joint systems, and also all joint testing standards allow for imposing a cyclic movement before the testing to simulate real construction environments. For perimeter joints, ASTM E2307 tests multi-story curtain wall setups, and EN 1364-4 focuses on the spandrel area section of the curtain wall only. The rating or classification principle remains the same as it does for penetration in joints. On this occasion, it's really important to mention the situation for rain screen cladding systems. Here we have the NFPA 285 and BS 84141, which are medium and large scale testing standards, and they do not include ratings. These standards should not be mixed up with the ASTM E3307 or EN 1364-4. They serve completely different purposes.
Very nice, Konstantin. So many a times you have we come across this question that is there a difference between testing and certifications? Would you give us a brief interview on what is the difference between testing and certification?
Absolutely. So testing and certification, this is really important to understand. Let's start with the test report and the testing. We use the example of a ULEU certification scheme because this is what most of you would be familiar with. Test reports, as you see on the left side, they contain observations of product performances at the time tested. Test reports are snapshots of performances presented in raw data, and for external people designing FIRESTOP application, this is not really of relevance. Then one or multiple test reports can be classified against performance criteria with the so-called DIAP, direct field of application, and EXAP, extended field of application, and then summarized in a classification report. And this is what you can already work with because they contain data on actual applications. Now, on the next step, all the way to the right, finally, a certification means that this set of application is presented including further characteristics, for example, VOC, acoustic performance, or air and water tightness. More importantly, though, third-party certification schemes certify a product with the use of auditing procedures, for example, the UL follow-up service, to ensure that the product quality is consistent and the product exhibits the expected performance for a long time after the initial testing was done. So, as a summary, test reports are raw data and snapshots. Certification in FIRESTOP means scope of applications and consistency. So to get FIRESTOPing right, you will be requiring certifications and not test reports. So on the next slide, you see an example. Besides the ULEU certificate of certification, that will be the European CE mark together with ETA assessments. These are official documents issued by a notified body accepted under the European construction law, and an ETA assessment itself is not publicly listed by a third party, but it may be listed publicly by the manufacturer. Whilst the ETA itself is an assessment at a given time, the COC document you see on the top right side, which goes along with the ETA and is referenced with the ETA, ensures the quality consistency on the highest level and the product manufacturing, which is observed over the official factory process control system. Now, let's take a look how this looks on the American side of testing. So under UL testing, fire test results are directly transferred to a so-called UL listed system. The extent of DIAP and EXAP rules are less than under European certification schemes, and the listing itself, that's the result of the testing, is online available under the Euro Product IQ, which can be accessed by a free of charge account. The listing goes along with the UL classified mark you see on the bottom on the product itself, and this certifies the product performance and also that the manufacturing is observed under the UL follow-up service. Now, here you will see an example of a UL listed system on the Fischer FBB UL FIRESTOP block. And in a UL listed system, as you can see, the application is described in a really detailed level, and it's leaving no room for interpretation to ensure that the installation on site replicates the tested system almost exactly. Now, let's put it all together. And here you will probably see some familiar logos and marks. And on the left side, you see certification schemes, and on the right side, you see different testing standards. So UL, which we all know as a testing laboratory, does testing based on both ASTM and EN standards and issues test reports, certifications, and marks. If testing is done with UL under an EN standard, then we will get a UL EU third-party certification. And if it's done as per ASTM UL standard, then we get the UL US listing. You also see some other logos like the ETA CE mark, Intertek logo, Warrington certifier, and they're all well known. And the UAE Fire Life Safety Code contains a list of several of these agencies which are accepted in the UAE. Now, what does it mean for Fischer as an international company? We, as Fischer, also work with an international product range. This means we have products tested to European standards, certified under CE mark and ETA, as well as UL EU. And we also have some certifier Warrington documents. And we also have, because we are an international company, around 400 UL listings and UL classified products, and the listings increase monthly. And under European testing, you usually get one certificate which covers many applications. Under UL testing and US listings, you usually get one listing per one application, which can incorporate more than one product.
So at Fischer, we have, as Konstantin rightly said, we have more than 400 listed systems under the American tested scheme, as well as we have nearly 11 products which are tested under the European norms, and they have listing which result in more than 400 different cases, thereby ensuring that your project is safe, and we will ensure that all your solutions as required are met. So it is very clear that FIRESTOP is a system. It has a testing standard, and then there is a certification scheme. So what is most important is the certification rather than the test report itself. So when we talk about a system, there are certain parameters that are there within the system. For example, the substrate, whether the penetration is through the wall or floor, what kind of wall or floor is there. Secondly, you would have the penetrant type and size. So what are the types of the penetrant, including if there is a pipe, what type of pipe it is, what is the size. Then we have the insulation type and size. If there is an insulation on top of the surface, then we have the very important annular gap and the joint width. So the gap between the penetrant and the periphery of the opening, and the gap between the two adjoining assemblies, that is called as joint width, and the annular gap. This also is mentioned within the system test itself. Finally, the backer and the sealant is given. Now, essentially, the actual field application should match the tested system. But as we all are in the construction side, we know that there is an ideal world where we do the testing, and then we come across this real world where the parameters might not match. In the ideal world, we do a proper coring and proper everything, so we make sure that the annular gap and everything is maintained and those are reported properly. But when you go to the site, unfortunately, the FIRESTOP planning is not there from the beginning. So the one who is making the breach or the opening, the civil contractor, sometimes does not coordinate with MEP contractor, and he might end up with an opening which is giving you an annular space much larger than the planned system. So because of these, many a times these parameters which are listed in the system do not match. So Konstantin, how do we solve this problem? What do we do when the listed system parameters do not match with our actual field application?
So it's a good question. In this case, we don't leave our customers alone. And in these cases, Fischer issues something called an engineering judgment. And so also known as EJ, and engineering judgments are based on the guidelines set out in the IFC, International FIRESTOP Council, and in-house experience and extensive internal tests by Fischer. The engineering judgment issued by the manufacturer are acceptable within the UAE Fire Life Safety Code. And it's really important, though, to mention that EJs cannot be issued in lieu of tested systems. And EJs are always issued only to specific project and specific applications. So, as a summary, engineering judgments can be issued if there is a scenario where there is no direct test evidence to support the specific application, but, and this is really important, if existing test data allows for interpolation or extrapolation. The author has to have sufficient experience and must be granted permission by the manufacturer to design engineering judgments. However, also engineering judgments do have their limitations, as we will explain on the next slide. EJs cannot and will not be issued by a manufacturer if a tested system exists, if the test evidence the manufacturer holds is insufficient, if the request is technically nonsense, that also sometimes happens, and if not all information needed to judge an application has been provided to the manufacturer. And it's really important that we always keep in mind, whatever we do in fire stopping, we are always responsible for people's life safety.
Great. Thank you, Konstantin. So with that, the most important point you have mentioned here is that we as Fischer, we take life safety very, very seriously. So you can be rest assured when you come to us, we behave as consultants, that we tell you what is the right thing to do at the right time to do. So at this time, I believe we have taken enough time, and let us, before we go into the questions, let me just inform you again that this session is only the session where we are concentrating on explaining you or giving you a brief idea on what is going on behind fire stopping before it reaches your hand. So we have done an extensive amount of research, extensive amount of testing, third-party testing, certifications, so that when we come to your site, you have peace of mind that you have somebody professional who's taking care of one of your problems in a professional way. Just as a reminder, we will be holding our third series soon. In the third series, we will be talking about the essentials of the correct applications. We'll be debunking some myths, and we'll be showing some of the applications related to Fischer. So we'll show you how we can give you very, very effective, efficient solutions that you could use on your project site. Please use the question answers pane to ask your questions. And now we move on to the question answer session.